Question 1. What are the two fundamental architectural principles that distinguish Amazon Redshift from traditional relational databases and enable its superior performance for online analytical processing (OLAP) workloads? Option A. Row-based storage and single-node processing. Option B. Columnar storage and massively parallel processing (MPP). Option C. In-memory caching and distributed transactions. Option D. Block-based storage and eventual consistency. The correct answer is columnar storage and massively parallel processing (MPP). Here's the explanation. The Amazon Redshift overview clearly states that Redshift employs a columnar storage architecture and massively parallel processing (MPP) to achieve superior performance for analytics, business intelligence, and reporting. These are the core differentiators for OLAP workloads. Question 2. In an Amazon Redshift cluster, which type of node is responsible for managing client connections, optimizing query plans, and coordinating the parallel execution of queries across the cluster? Option A. Compute node. Option B. Leader node. Option C. Redshift Spectrum node. Option D. Concurrency scaling node. The correct answer is Leader node. Here's the explanation. The study material defines the leader node as the component that manages client connections, receives queries, parses and optimizes them, and coordinates the parallel execution across compute nodes. Compute nodes store data and execute query segments, while Redshift Spectrum and concurrency scaling are features, not node types, with these specific responsibilities. Question 3. A data analytics team needs to perform ad hoc queries on petabytes of raw, semi-structured data stored in Amazon S3, and also combine this data with more structured datasets already loaded into their Amazon Redshift cluster. To minimize data loading time and storage costs within Redshift, which feature should they leverage? Option A. Concurrency scaling. Option B. Workload management (WLM). Option C. Redshift Spectrum. Option D. Result caching. The correct answer is Redshift Spectrum. Here's the explanation. Redshift Spectrum allows you to query data directly from files stored in Amazon S3 without loading it into Redshift. This is ideal for integrating with data lakes in S3, reducing the need to load vast amounts of data into Redshift for analysis, and thus saving on storage costs and time. Question 4. A company wants to migrate an on-premises Oracle database to Amazon Aurora PostgreSQL with minimal application downtime. Which AWS service combination is most appropriate for this scenario? Option A. AWS Snowball for data transfer and manual schema conversion. Option B. AWS Database Migration Service (DMS) for data movement, and AWS Schema Conversion Tool (SCT) for schema conversion. Option C. AWS DataSync for file transfer and AWS Glue for ETL. Option D. Manual dump and restore operations with an EC2 instance. The correct answer is AWS Database Migration Service (DMS) for data movement and AWS Schema Conversion Tool (SCT) for schema conversion. Here's the explanation. Migrating from Oracle to Aurora PostgreSQL is a heterogeneous migration, different database engines. AWS SCT is used to convert the schema and code objects, while DMS handles the actual data movement with minimal downtime using Change Data Capture (CDC). Question 5. What is the primary function of a DMS replication instance? Option A. It stores the migrated data temporarily before writing to the target. Option B. It converts the database schema and stored procedures for heterogeneous migrations. Option C. It is the compute engine that runs the DMS replication tasks, connecting source and target databases. Option D. It provides network connectivity between on-premises databases and AWS VPCs. The correct answer is, it is the compute engine that runs the DMS replication tasks, connecting source and target databases. Here's the explanation. The replication instance is the core compute engine managed by AWS that performs the actual data replication, connecting to both the source and target databases, reading data, formatting it, and writing it to the target. It is provisioned in your VPC. Question 6. Which DMS migration type is typically used for critical production workloads requiring the lowest possible downtime during migration? Option A, full load only. Option B, CDC only. Option C, full load and CDC. Option D, schema conversion only. The correct answer is full load and CDC. Here's the explanation. For minimal downtime migrations, DMS performs an initial, full load of existing data and then immediately switches to change data capture, CDC, to replicate ongoing changes in real time. This keeps the target synchronized with the source, allowing for a quick cutover. Question 7. A company is planning to migrate its on-premises Oracle database, which contains complex place/SQL stored procedures and functions, to Amazon Aurora PostgreSQL. Which AWS service is primarily responsible for converting the database schema and application code from Oracle syntax to PostgreSQL syntax? Option A, AWS Database Migration Service, DMS. Option B, AWS Schema Conversion Tool, SCT. Option C, Amazon Redshift. Option D, AWS Glue. The correct answer is AWS Schema Conversion Tool, SCT. Here's the explanation. SCT is specifically designed for heterogeneous database migrations, converting database schema objects, tables, indexes, views, and procedural code, like stored procedures, functions, triggers, between different database engines, e.g., Oracle PlaceSQL to PostgreSQL. AWS DMS is for data migration, not schema/code conversion. Question 8. What is the primary output and most valuable aspect of the AWS Schema Conversion Tool, SCT, during a heterogeneous database migration? Option A, a real-time data replication stream from the source to the target database. Option B, a fully converted schema and application code that is guaranteed to be 100% compatible. Option C, a detailed assessment report highlighting conversion complexity, manual effort, and recommendations for problematic objects. Option D, an automated batch job for bulk data transfer to the target database. The correct answer is a detailed assessment report highlighting conversion complexity, manual effort, and recommendations for problematic objects. Here's the explanation. The study material emphasizes that the assessment report is the heart of the tool's value. It meticulously details compatibility, identifies objects that can be automatically converted versus those requiring manual intervention, and estimates the manual effort, making it a critical planning tool. SCT does not guarantee 100% automatic conversion, nor does it perform real-time data replication or bulk data transfer. That's DMS's role. Question 9. A database administrator is performing a heterogeneous migration from a Microsoft SQL Server database to Amazon Aurora MySQL. After running AWS SCT, they encounter several stored procedures that SCT could not automatically convert. What is the expected next step for these unconvertible objects? Option A, immediately proceed with data migration using AWS DMS, as SCT will handle these during runtime. Option B, manually rewrite or refactor the problematic stored procedures to be compatible with Aurora MySQL. Option C, rerun SCT with different conversion rules until all objects are 100% automatically converted. Option D, contact AWS support to request a custom conversion plugin for SCT. correct answer is manually rewrite or refactor the problematic stored procedures to be compatible with Aurora MySQL. Here's the explanation. The study material states, for elements that cannot be directly translated, SCT often inserts comments or placeholders in the generated code, clearly marking areas that require manual review and modification by a developer or DBA. It also notes that it's rare for a complex heterogeneous migration to be 100% automated, implying manual effort is a necessary part of the process for complex objects. Thanks for watching. Please subscribe to my channel.